Hi everyone, and thank you so much for joining me today on this YouTube channel. My name is Penny, and this is Penny's Coding Bits. This channel is dedicated to bring you weekly bite-sized videos with practical solutions to your everyday data analytical challenges. And this video is going to walk you through the code that identifies objects in images. And this is the baseline technology that supports many of the emerging technologies, such as facial recognition. Well, before we begin, if you're interested in joining a group of coding enthusiasts live in a meeting setting, please go to the sign up page in the description box below to sign up for the CodeChat that is happening this Friday, November 24th at 5 p.m. Eastern Time. Alternatively, you can directly go to the meeting link in the description box at the time of the meeting. Well, without further ado, let's get started. So, in order to separate objects from the backgrounds in an image, we need to set a formula that maximizes the difference between the foreground and the background of an image. And the threshold based segmentation is the methodology that we will use to do this. And specifically, we will use the Ozu's threshold to operationalize this process. So let's first walk through the process in MATLAB to do this object recognition in images. First, we read in this image called cameraman, which is this image right here. But in order to separate the foreground of this picture, which is the cameraman, from the background, which is the sky, the building, and the field, we need to analyze each and every pixel in this picture and separate those pixels into two groups. In other words, we need to convert this grayscale picture into a black and white picture. And in the process of doing the separation, we need to set a threshold. And that's where this Ozu's threshold comes in. Ozu's threshold automatically assigns a threshold between the highest brightness and the lowest brightness in this picture so that the foreground and the background variance are maximized and the variance between pixels in the background is minimized, and the same with the foreground, so that the background and the foreground are essentially separated into two groups. So let's see how this works in MATLAB. So the first step is to come up with a histogram of all the pixels. So you can see here that the x-axis represents the pixel intensity. So this represents the brightness of each pixel that we pick up from this image. And the frequency, of course, is the count of how many pixels we come up with for each intensity level. So thus, this corresponds to this formula right here. The count is the y-axis. The bin location is the x-axis. So the brightness of each pixel determines the bin location of where that pixel belongs. And we are formulating this with the image that we have imported, and we are formulating a histogram with the image. And we set another grayscale threshold with the image, and usually grayscale images come into 255 bins. So that's the length of our x-axis. This is how many bins there are. So that's plotted here. So this is essentially a distribution plot of the image brightness of each pixel. And after we calculate the Ozu threshold, we can use this to separate our pixels into the two groups. So whatever is above this threshold belongs to the bright group, and whatever is below this threshold belongs to the dark group. And that way we can separate out the background and the foreground into distinct two groups. So that's the baseline operation of what we're doing here. And so we can plot the histogram, and that comes up to this, with this threshold right here being the OSU's calculated threshold. Now we can see how this is working in Python. So instead of one line that reads in the image, we have the CV2 image read command. So CV2 is a computer vision module in Python that takes care of computer vision operations as well as image recognition operations. So we use that to read in our cameraman picture, and that is a grayscale picture. And instead of specifying 255, in Python, we need to specify 256 because 0 counts as a number as well in that range. And Histogram, this is essentially flatten the picture into a 2D diagram. And we can calculate the OSU's threshold, and this belongs in the filters module in the sklearn. So many of you are familiar with the scikit-learn package, which is a machine learning package within Python. So skimage is the image module of sklearn, and we are dealing with the filters subcomponent of that module to come up with our OSU threshold. So this line is essentially in place for this line right here in MATLAB to calculate the threshold. And similarly, we can plot this, and this histogram came up to be looking like this in Python. Now, we have the histogram laid out, and we know how the background calculation is working. Now, let's apply this to the image and see how the outcome is coming out to be. So the code for coming up with the recognized object in MATLAB is as follows. So same with before, we read in the image and display the original image. But in addition to the grayscale threshold formula we had before, we need a binarized formula. So the bright parts of the image are all being converted to white, and the dark parts are all being converted to black. So it's a binarized image instead of a grayscale image. And we can simply say, please show this image and add a title to it. So let's see how this is working. There. So that's our original image, and this is the segmented image using the OSU's threshold. So you can see all the gray parts are being converted to white, and the black parts are all being retained so that we have a binarized black and white image. The same is holding in Python. So we use our filters module to set the threshold as before, and we say black and white image is equal to the image above this level, so that everything else are being whited out. And then we simply display the image, and here it is. So that's a quick and dirty way of recognizing an object in an image. I hope that's helpful for you. I'll see you in the next video.